Okay.
Mathematics help us to understand the world and provides an effective way of building mental discipline. Good morning, students. I welcome you all for the second day of induction program on the topic application of mathematics in engineering. People who feel good about themselves to great work and create great things. Now let me introduce our chief guest. It's my privilege to introduce the guest of honor for the day, Dr. K. Geeta, Assistant Professor, Department of Mathematics, Queen Mary's College, Chennai, for the first year induction program 2021 of SA Engineering College. She has completed MSc in 1994 and MPhil degree in the year 1995 in mathematics from Pachepas College. Worked in St. Peter's Engineering College for 4 years. Then worked in SA Engineering College for 9 years as assistant professor and head of the department in mathematics. Joined government service in 2009 as assistant professor and currently working as assistant professor in the Department of Mathematics in Queen Mary's College, Chennai. She has participated and presented papers in national and international conferences. It's our privilege to have you as our guest of honor, ma'am, even in spite of your busy schedule. We thank you for this. I'll hand over the session to Dr. K. Geeta.
Thank you, madam. That was a nice introduction. Good morning, everyone. So, I'm here to present on the applications of mathematics to engineering. So, I hope you are all first year students who have joined engineering in various disciplines. And you have completed, of course, 12 years of studying mathematics already in school. Now, because you have joined a professional college, you are going to apply mathematics widely in your area. So, depending upon which discipline you have taken, the selective topics of mathematics you'll be applying in your areas. But here, I'm going to give you a few applications which covers broadly all areas of engineering. So here I start sharing my screen. So we are going to see some of the applications of mathematics to engineering. So to begin with, I'm going to start with functions. Now, in your primary school, you have studied about arithmetic and operations like multiplication, addition, subtraction, division, which we do on numbers. And as you grew to high school, you studied a little bit of algebra. And then in your higher secondary, you have been introduced to what we call as functions. Now, your understanding of function goes like this: y equal to f of x. Is it not? Now, I just want to tell you something about functions, some analogy that will help you to always identify what function is. Suppose you want to buy clothes. You are entering a clothes store. How your expectation in the clothes store will be, how you want the clothes to be arranged. Do you like all the clothes to be mixed up and put it in one place? How will you feel like shopping in a shop where all the clothes like pants, shirts, salwars, saris, everything mixed up and put it in one haul? Will it not be a disastrous shopping for you? So we want to go into a shop where all dresses are arranged and neatly stacked. Is it not? So in the same way, in mathematics, we have got a lot of expressions. Those expressions which we want to take and use, we are to be classified and be given some name. And for that, we make use of functions. Now, we always define a function on a set to a set x, on a set x to a set y. That we call as a well-defined function. So a function is defined on a set to a set y. And you have already studied what we mean by a set. A set is a collection of objects. Now, this set X, we give a name to it, which we call as a domain. And the set Y is given the name codomain. So the set on which a function is defined is called as domain, and the set to which the elements of X are transferred to or taken to is called as the set Y. Now I have given a small graphical representation or diagrammatic representation here. This is only a representation. Now you see the set X and the set Y here. Now the elements in X I have denoted with X, and the elements of Y I have denoted with Y. This capital X set we call as domain, and this set Y we call as codomain. You can even give the name range. Now you see the function y equal to f of x there. It is showed with the help of a small curve. Now elements of x are to be associated or taken to elements of y. The distance doesn't matter here. The actual distance doesn't matter here. Now you define the function f of x. The elements in the set X will be taken to Y. That's it. It's very simple. It is as simple as you being transported from one domain to the other domain by simply using the function f, and the distance, how much distance is there between X and Y doesn't matter at all. Now, this is a formal notation we use. You are very much familiar with this. F of x is defined on x, and it is a function from x to y. As I already told you, the set x is called as domain, the set y is called as codomain. So you are defining a function from x to y. Now here, what are the types of the set? So depending upon the types of set and depending upon the types of function, we come across variety of functions. Now, x, the set x can be a set of real numbers or complex numbers. If you are familiar with other sets like that is three-dimensional space or n-dimensional space, sets can be defined in those spaces also. Y can also be a set of real numbers or complex numbers, or it can be a set in a three-dimensional space or n-dimensional space. So these are the possible sets which we can give for x and y. Now coming to the function f, generally a function can be classified broadly into 4 categories: algebraic, trigonometric, exponential, logarithmic. Algebraic functions are nothing but powers of the variable x if you are using the variable x. Trigonometric functions are those functions which are defined using the angles of triangle, that is sine, cos, tan, etc. Exponential functions are e power x, a power x, 2 power x, Those are examples for exponential functions. And of course, logarithmic functions, you're all familiar with log x to any base. So you give me any function, I can put it in any one of these four categories. So we are going to play around this function and this set of domain codomain. That's it. So this is a basic idea which your school mathematics would have taught you. And of course, in your school, in your high secondary, you have been introduced to operations on functions. If you could recall, there are two important operations on functions: differentiation and integration. Just as we have this multiplication, division, addition, subtraction to be operators of arithmetic on numbers, differentiation and integration are operators on functions f of x. So before going to differentiation and integration, I just want to give you a small idea on the probable uh, probable probability of the x and y being real and complex. Now we have seen f of x is a function from x to y, and if x, the set x, the domain x is a real set, that is, it is taking the real values, and your y is also giving you the real values, we call it as a real valued function, a function from real x to real y. Now, suppose your x is a real and y is complex. That is, y is a set of complex numbers. That is, your function is going to take complex values. Then it is a function from real x to a complex y. Now, this is also possible. That is, x being a set of complex numbers and y being real. Now, I can give you an example for it. If your x is a set of complex numbers, an element can be z, which is x plus iy, and I can define the function as what? F of z equal to mod z. Then modulus value of z is a real value. So this function becomes a function from complex domain to a real domain. And again, we have x being complex and y also being complex. And those are functions which help us to take complex numbers to complex numbers. I can give you an example here also. F of z equal to z square, where z is x plus iy. Then that function takes z to z square. So here the domain is also a complex plane, and the codomain is also a certain complex plane. So that is mapping from complex plane to a complex plane. Now, once again, coming to sets, we saw the set x and y, domain and codomain, can be real, complex, etc. Now, here again, the range of the sets can be classified in this way. It can be an open set, it can be a closed set, it can be a convex set, it can be a compact set. And what do you mean by an open set? An open set is one where the ends, that's the boundary of the set, is not included. A closed set is that set which has got its boundary points to be included. A convex set is a set where any two entries or any two elements of the set can be connected by a line, a straight line. A compact set is a set which is both closed and bounded. So your domain and codomain can belong to any one of these categories. It can be either an open set or a closed set or a convex set or a compact set. Of course, we have many other types of sets also in this line. Now, coming to the topics covering engineering mathematics. You're already introduced all these topics in your school. Calculus both integral and differential. You have studied integral calculus as well as differential calculus, and you are going to study of a continuation of those in your engineering mathematics. Angles, triangles, and trigonometry is widely applied in all areas of engineering, especially electrical and mechanical engineering. Geometry, you're going to study about analytical geometry. Analytical geometry is nothing but a study of geometry theoretically, where all the shapes are going to be defined using equations. And then equations, the polynomial transcendental equations, system of equations. You have already solved polynomial equations in your school mathematics. Quadratic equations you have solved. You have solved cubic equations. Now suppose you are given equations of higher order, higher degree, say x power 5, fifth degree equation. How will you solve it? And suppose your equation contains logarithmic terms, trigonometric terms, that is sin x cos x. Your equation involves sin cos terms, log terms, exponential terms, etc. Then we call that equation as a transcendental equation. And how we are going to solve transcendental equation? And system of equations means a set of uh, two or three equations and two or three unknowns that you would have already studied in your school mathematics. But here we are going to study a few more methods of solving system of equations. And all this will be covered in your first year mathematics. And then we move on to differential equations. Differential equations, you have got two types, which are ordinary and partial, depending upon the derivatives, whether the derivative is going to be ordinary or partial. And that again depends upon functions, whether your function is a function of one a single variable or two or more variables. If your function is going to be a function of more than one variable, then will be coming across like z equal to f of x comma y, and there x and y, the two variables being independent variables, you have to differentiate with respect to one variable at a time, and so you come across partial derivatives and hence partial differential coefficients. So any equation, a differential equation containing partial differential coefficients we call as partial differential equations, and any equations containing ordinary differential coefficients are going to be called as ordinary differential equations. So these two type of equations you will be coming across in your engineering mathematics, and their applications also will be interesting. And then, of course, different discrete mathematics. You have discrete mathematics of actually is going to play a good role in electronics and computer science engineering. And here, this number theory and logic of discrete mathematics you are going to apply in your engineering. And of course, finally, probability and statistics. Probability and statistics, you have that also you have been introduced in your school mathematics, and here probability and statistics also find its application in a random process, which is going to be a subject in electronics engineering. Now let us move on to some applications of differential calculus. Now I'm going to give you one or two applications only, and this also you would have already studied in your school physics. Those two applications only I have taken. Now, what is actually a derivative? When I ask you give me a derivative, you will immediately say dy by dx. Is it not? So, what is dy by dx? The formal definition is actually the limiting case of the ratio of change of y with respect to x. Now that being the formal definition of derivative. So what does it actually do there? It is actually capturing the change. So derivative is just like a camera in the hands of a cameraman. So you are going to a place like Ooty, Kodaikanal, and what do? the important thing you take along with you is the camera. And nowadays everyone has camera in their hands, that is mobile phone. You take pictures, is it not? So those pictures tell us what happened there, is it not? So in the same way, you want to capture the change that has taken place. Now you are in your room, you want to go to your college, so you dress up and go to the bus stop. So the distance from your house to the bus stop is calculated, and the time you have taken to move from your house to the bus stop is also calculated, and you make the ratio of the distance and the time. And if you find the limiting case, that we call as what? The rate of change of distance with respect to time. And we give that rate of change the name velocity or speed. So the rate of change of distance with respect to time is velocity. So in the same way, you can capture the rate of change of energy with respect to time as power. And one more application in physics or for electrical engineering students, the rate of change of flux linkage with respect to current is inductance. So you can find out the rate of change of any variable with respect to any variable. In the first case of velocity, you're capturing the rate of change of distance with respect to the variable time. In the second case, you're capturing the rate of change of the variable energy with respect to the variable time. And in the third case, you're capturing the rate of change of flux linkage with respect to the variable current. And now suppose you want to find out the rate of change. The rate of change that will give you the second order derivative, d square y by dx square. That is the second order derivative. So second order derivative means what? It is a rate of change. Okay, so one example I can give you, and that is acceleration. So acceleration is what? The rate of change of velocity. Okay, so velocity is already a rate of change of distance with respect to time. And what does acceleration finds out? It's giving you the rate of change of velocity. So that is the second order derivative. And whatever we have discussed there, I've just given you here. Velocity is given by v equal to dx by dt. X is a distance and t is a time. X is a variable representing distance, t is a variable representing time. Now power is given by P equal to dW by dt, where W is a variable representing energy, and T is the variable representing time. And in the third example I gave you application, the inductance is given by L equal to d psi by di, where psi is flux linkage and I is the current. Now let us move on to integral calculus, and we'll see some applications there also. Integration. What does integration means? Integration symbol you all come across. It is just an elongated S. The integral symbol is just an elongated S symbol. What does S stands for? It is standing for summing up, the sum or the total. So integration is a mathematical operation that sum up or total up the desired quantity. So whatever quantity you want to sum up, you can do it using integration. So that is the job which the mathematical operation integration is doing. Now, one application is area under or covered by a given curve is integral over C f of x dx. F of x is the curve. So usually the curve is given by an equation y equal to f of x. So that f of x is a function which is representing the curve, and you are integrating that function with respect to the variable x over the curve c. So whatever limits given by the you want to integrate, between which you want to integrate, you can use those limits, and you can get the desired quantity, which is the area. And now I can give you an example here. Now suppose uh, a cowboy wants to is taking a cow to graze. He's taking to a grass field, and he has got a mobile in his hand, say, and he wants to spend time with this mobile. Now, what does he do? He ties the cow to a pole on the in the grassland, and simply forgets about the cow. So the cow will not go anywhere. It simply grazes the grass there. Now, at the end of the day, he wants to find out the area of the grassland which the cow has grazed. So what is that? We will use a mathematician. If the boy is a mathematician, what he'll do? He will simply find out the center of the pole and find out the radius of that circular area which the cow has grazed, and then uses integration. The f of x is to be taken from what? Where? The equation of the circle. And he puts it in this integration, under this integration symbol, and he finds out the area. So it's as simple as it is. So then we'll move on now to a little bit to mechanics. The second application I've given you here is work done by a force acting on a particle to describe a curve C. Now, imagine you are in a corner of a room. You want to push a table to other end of the room. So what do? You apply some force to the table. You can take the table from one corner of a room to the other corner in any path. You can take it along a straight line, or you take it in a curved way, zigzag manner, with whatever you wish. So, C is the curve which is describing the path along which you are moving the table, and F is the force you have applied on the table. And you want to find out what is the work done by you. Suppose your mom asks you what you have been doing in the room, sitting idle. Now you can say, I have just pushed the table from one corner of the room to the other corner of the room along the curve C, and I have calculated the work done by me in pushing the table, and you can give the work done by you. So what you have to do? You have to simply integrate f dot dr. Here f and r vector is a position vector, and f vector is a force vector. Force is a vector quantity, and you make the dot product of it, and you integrate that quantity along the curve, along the path which the particle has been moved, and you can get the work done. Now let us move on to some number theoretic applications. So I already told you in discrete mathematics, two topics are of important applications in electrical and computer science engineering. So one of it is number theory, the other is logic. So only these two topics I have taken from discrete mathematics. One important concept in be it electrical or electronics or computer science or information theory, there the speed is important. You have your mobile phones, you have your laptops, PCs. Now, what defines the quality of the phone or the laptop? The specifications, where you look for the specifications like a RAM, is it not? So it defines the speed of the laptop, its speed of the mobile phone. This time estimate is giving you a rough calculation of the time taken to do a task. You're downloading apps, you're downloading from Google. Now your laptop downloads whatever you want in a fraction of second if your laptop has got more RAM, is it not? So that is defined by the time estimate in doing the task. So here I'm just going to give you a small glimpse of what is being done there. Now, the numbers can be written in any base B. The ordinary numbers we use, they are all base 10 numbers. The usual number is in decimal system has base B equal to 10. Numbers in binary system has base B equal to 2. And the numbers of digits of a number n in base B is given by log n to the base B plus 1. So what is that we are actually doing here? Now suppose I'm giving you a number in decimal system, say 125. And you all know how to calculate how this binary, in binary system, how to convert this 125 into binary number. And once it is converted, we call it as a number in base 2. Now, I want to know how many digits are there in the binary representation of 125 without even calculating it. So what I do here is I make use of this simple formula log n base b plus 1, where log n is given in square brackets, and that means the integral part of that log n base b is taken, and together with that 1 is added. So this gives the number of digits in the number n. Now, why this is important? The number of digits of a number n in base b. Why is this important? Because you know that any task you give to the computer, it breaks it down into binary language. And everything is converted into binary, and the work is being done only in binary. So, the task is being converted into ones and zeros. Whatever task you give, downloading of a app or downloading anything from Google, anything for that matter, your computer or laptop converts it into what? Ones and zeros. And that once a task is converted into ones and zeros, their computation takes place with ones and zeros only. And therefore, the multiplication or addition, subtraction are taking place in binary system. And so the number of digits in the binary representation is important. So the operation which you are doing with binary numbers is called as a bit operation. So bit operation is that we do on binary numbers. Bit is a short form of binary digit. So more complicated tasks can be broken down into bit operations. So the amount of time a computer takes to perform a task is essentially proportional to the number of bit operations. So as I already told you, the computer breaks down the task which you give to it into bit operations. So how many bit operations the task is taking, that is important, is it not? So that is why we find out the number of digits of the binary representation, and how many bit operations is taken to do the task. Now, suppose adding 2k bit numbers. We are adding 2k bit numbers. Now, what is the number of bit operations required to add 2k bit numbers? So, adding 2k bit numbers requires only k bit operations. Suppose you are adding a 4-digit binary number with a 4-digit binary number. How many additions you are going to make? So you added digit by digit, and there are 4 digits, and therefore 4 additions. So adding 2 k bit numbers requires k bit operations. It is as simple as that. Multiplying a k bit number with a L bit number requires less than k into L bit operations. So Here, what operation we are doing? We are multiplying two binary numbers. One binary number has k bits, and another binary number has l number of bits, and you are multiplying these two numbers. It requires only maximum of k into l bit number of operations. Now, the time estimate for carrying out a task find its application in microprocessors which work with RAM or ROM. So, microprocessors, or we find its application in electronics and computer science. So here the time estimate is having its finding its application. Now I've just given you a small example here, time estimate for binary multiplication. Here I have taken a 5-digit a binary number, and I'm multiplying with a 4-digit binary number. I'm making use of the binary multiplication process, which we are all familiar with. I'm multiplying and I'm getting a result there, and I'm getting a what a final answer, which is also a binary number. And the time estimate to multiply the 5-bit number with a 4-bit number requires less than k into L, which is 4 into 5 is equal to 20 bit operations. This is how we calculate the number of bit operations required to do a task. Here example I've given you is binary multiplication. Now, I move on to applications of logic. Logic is a subject which you are also introduced to in your school, high secondary most probably. And if I can tell you the truth values, the truth table, you can immediately recall what you studied there. And the binary and unary logic operators, or and or not. We the truth values, true or false, are being operated by this logic operators and or not. Now, one application of this logic operators is logic gates. The logic gates are simple circuits that take input signals and send out output signals. What are input signals? Input signals are nothing but ones and zeros. Okay, that is either true or false. The truth value being true or false is given the representation 1 or 0, and we call them as signals. So the logic gates, what they do, they are the simple circuits which take in the signals ones and zeros and gives out output and signals which are also in ones and zeros. The logic gates are widely used in logic devices. I have given you one example, decoders. Logic devices like decoders find usage in electronic devices. Almost all electronic devices use these logic devices. Example, the mouse you use in your laptop or your laptops or computers with the remote controls are all examples of the logic devices. And logic finds its application in inference theory also. Inference theory is a part of a computer science field, and the logic finds its application in inference theory as well. Now, I'm going to give you application of other mathematical structures, discrete mathematical structures. Discrete mathematical structures like sets, ordered sets, lattices, graphs find their application in the following areas of computer science: data structures, storage structures, sequential allocation, pointers, and linked allocation. So, this is especially for computer science students. Data structures, what you study there is nothing but breaking down complex data into simple form. You are given enormous data and you want to study the data. What do? You break it down into simple forms of data using graphs like trees. What is the structure of a tree? It is having a root, it is having branches, it is having end branches and leaves. is it not? So leaves are the smallest unit in the data structure, in the tree structure, and then comes branch, and then the roots. So, using the simple tree graphs, you'll be breaking down complex data into simple data structures. The same, whatever you do there in data structures, you're going to do in storage structures as well. In storage structures in read only memory type, you have this storage structures using discrete mathematical structures. And sequential allocation, of course, it is allocating the task in the whatever sequence you want. Pointers and linked allocation, there again, to whichever allocation you want to point to, you can do it using these discrete mathematical structures. And now I want to wind up this session with one application of differential equations. So I already told you differential equations, there are two types. Ordinary differential equations, which involves ordinary differential coefficients, and partial differential equations, which involves partial differential coefficients. Now, one application of differential equation I'm going to give you, which is the velocity of escape from Earth. So we are not going to escape from Earth, but we can make objects escape from Earth, satellites, rockets launching, etc., etc. Now, what is the problem here given to you? The problem is to find the minimum velocity with which a body has to be projected vertically upwards in the radial direction from Earth so that the body will escape from Earth and will not return to Earth. So, we are looking for the minimum velocity with which a body has to be projected vertically upwards in the radial direction from the Earth. So, we want the body to escape from Earth and the body should not return to Earth. So, you can think of satellite launching in that case. So it is assumed that the retardation effort due to air resistance and the gravitational pull of other celestial bodies are neglected. So why we are given this? Because air is giving you an enormous resistance. The resistance of air is enormous. But anyway, compared to the velocity with which a body has to be projected, this air resistance is minimum. So the air resistance is neglected, and also the gravitational pull of other celestial objects. Other celestial objects, you can think of moon or nearby stars. Though it is not visible, all other celestial objects are also putting their effect on us, is it not? So, when launching a satellite, so it is assumed that retardation effort due to air resistance and the gravitational pull of other celestial objects are neglected. And with this assumption, we are going to find out what is the velocity with which a body has to be projected. Now, the vertical motion of the body is described by the second order ordinary differential equation. I have given you an equation here. M d square r by dt square equals minus k times capital M into small m by capital R square. This ordinary differential equation, which is of second order, is describing the vertical motion of the body which has been projected. So m is the mass of the body which you're projecting. Capital M is the mass of the earth. R is the distance between the earth and center of the body. And even though I have not given what is capital R stands for the radius of earth. Now, this equation is describing the motion, vertical motion. Now, we want the velocity with which the body which has been projected is moving. Now, what do? We have to integrate. We have to integrate this differential equation. You can imagine that differentiation and integration are opposite operations, opposite to each other. So, if you want to come out of the differential operator, you have to integrate. So you can solve this differential equation, which is a very simple differential equation, because much more complex differential equations are there. Now, this is a simple differential equation which you, when you integrate it twice, you get the solution, and that is going to give you the velocity with which the object you have projected is going to move. So if V naught is the initial launching velocity of the body from the surface of the earth in a radial direction, then the body will travel in space with velocity V given by V square equal to 2g r square by r plus V naught square minus gr. This expression is giving you the velocity of the body from the surface of earth in a radial direction, which the body will travel in space, right? So V naught is the initial launching velocity. So this equations gives us an idea what should be the initial launching velocity and what should be the velocity with which you want the rocket or a satellite to travel. So once you fix V, you can decide on V naught. You are fixing what is the speed of the body with which it has to be projected, and then you calculate V naught from this expression. Of course, G is the gravity and R is the radius of Earth. So I have given you an application of differential equation in space engineering, and of course all disciplines of engineering, electrical, be it electrical or computer or mechanical, they all have the opportunities or applications in space engineering. Now let me give you some more applications. A linear algebra is one branch of algebra, and it's finding its application in artificial intelligence. Artificial intelligence has got wide application, in robotics and in many other theoretical computation. So linear algebra is one area which is very widely used. Difference equation finds its application in numerical methods of solving differential equations. And your mechanical engineers, you will be studying thermodynamics or fluid dynamics. Any equation in thermodynamics or fluid dynamics are going to be partial differential equations. Partial differential equations you come across when the experiment, whatever you conduct or you are working on, has more than two variables. Of course, heat transfer in two-dimensional, say for example, you're considering the heat transfer in a plate. A plate is having two dimensions. And what is the rate at which the heat is transferred in the plate? So that will involve partial derivatives, and the partial differential equation, which is going to capture the heat equation, the heat transfer equation, we want to solve it. So it will be a partial differential equation. And the same way in fluid dynamics also you come across partial differential equations. And in real-time experiments, the partial differential equations you come across as a result of the experiment you have conducted is going to be very complex, and the mathematical solutions, whatever we have in analytical mathematics, will not be sufficient for you to solve those partial differential equations. Now, in that case, what we do, we take the help of computers, we make use of numerical methods of solving differential equations. Numerical methods, which is going to be a subject for you, I think for 2 semesters or 1 semester. This here you're going to study a wide number of methods, a lot of methods are there, which help us to solve difficult equations, algebraic equations, transcendental equations, this partial differential equations, ordinary differential equations, or even system of equations. System of equations we know to solve by matrix method, which is a mathematical method of solving. If the equations, a system of equations is going to involve decimal coefficients in the sense rational numbers are going to be the coefficients of your equation. In that case, how do you solve? We don't have any mathematical method, a closed form method to solve equations with fractional coefficients. So in such a case, numerical methods are going to give us a helping hand to solve all this type of equations. Now again, this partial differential equations find its application in fluid dynamics, thermodynamics, I have already told you, and also in image processing. Image processing is a topic of recent development, and their partial numerical methods of solving partial differential equations is used in image processing. And also the Fourier transform method is also one method which is also available. Laplace transform method is one method which is available to solve differential equations. You can use them also depending upon the nature of the equation. We use whatever method we have. So mathematics is offering you a wide number of methods which you can buy and use wherever you want. Now, graph theory finds its application in network theory. The graph theory is an offshoot of number theory, and as I already told you, tree structure or this discrete structures which we are going to use in computer science engineering for data storage, etc. This graph theory is finding its application. So graph theory is also used in network theory as well. So I have given you a few applications of mathematics. You being engineers, you can come to the shop of mathematics anytime, and you can buy whatever mathematical tool you want to for your usage, where you want to apply depending upon your application. You can buy the tool from the shop of mathematics, and you're going to enjoy the application. Now, one more thing I want to tell you is all those mathematical tools what the mathematicians developed is finding its usage and in science, engineering, and technology. And one recent development in mathematics is fuzzy mathematics. And to your surprise, you will see that this fuzzy mathematics is a new branch of mathematics. It has been developed by an electrical engineer. It was not developed by a mathematician. It is developed by an electrical engineer uh, from Israel. This fuzzy mathematics is finding its application in engineering, especially in electrical engineering. They are finding the usage of fuzzy mathematics in a lot of areas. So, with that, I want to conclude my session. If you have any questions, any queries,
Thank you is the best prayer that anyone could say. I say that one a lot. Thank you expresses extreme gratitude, humility, understanding. On behalf of our management, I would like to thank Dr. K. Geeta for sparing her time from her busiest schedule to grace this occasion. Today, we had an opportunity to hear your thoughts, and this will surely be going to encourage our students in future events. Once again, thank you, ma'am.
thank you. I thank you all for this opportunity, and I thank Dr. Harikara Sudan for giving me this opportunity to interact with the students. Thank you very much.
Thank you,
Thank
ma'am.
you,
Thank
ma'am.
you, ma'am. Thank you very much, ma'am.
All the best to all of you.
Okay, ma'am. கொடுத்துடலாம் மேம் நான் ரிமூவ் பண்ணிக்கிறேன் உங்களை
Thank you. Okay, okay.
ஓகே மேம் கண்டினியூ Kishore sir, good morning.
Yes, sir. Good morning, sir. Can you see my
ஆரம்பிச்சிடலாம் சார்.
screen, sir? Yes.
ஓகே.
Okay. Okay.
Now let us move on to the next session, orientation program in mathematics. Now let me introduce our chief guest. It's my privilege to introduce the guest of honor for the day, Dr. Kishore Kumar PK, University of Technology and Applied Sciences, Mathematics Session, Sultanate of Oman, for the second session of first year induction program 2021 of SA Engineering College. He has many qualifications to his credits. He has done BSc in Mathematics from JR College of Arts and Science in the year 2002, MSc in Mathematics from JR College of Arts and Science, University of Madras in the year 2005, MPhil in Mathematics from Alagappa University, Karaikudi in the year 2008, ME in System Engineering and Operation Research from CEG Campus, Anna University, PhD in Mathematics from Bharathiar University, Coimbatore in the year 2018. Uh, Diploma in Advanced Programming from WCT Chennai. Completed Typewriting English in Higher, Personality Development and Public Speaking course from Ramanathan's Public Speaking Institute, Adyar, Chennai. A course in Machine Learning from Credo System, Velachery, Chennai. Course in Deep Learning at GUVL. He has 14 years of experience as a lecturer and assistant professor in well-reputed college in Sultanate of Oman and Chennai. His area of specialization are graphs in uncertain environment, fuzzy graphs, vague graphs, and neurosophic graph theory, Python programming, machine learning, deep learning techniques. He has published chapters titled on fuzzy critical graphs on the topic fuzzy critical graphs in advanced engineering research and applications, and a new concept of matrix algorithm for MST in undirected interval valued neurosophic graph in neurosophic orientation uh, research. He has research publication in 5 Science Citation Index expanded journals, 7 Scopus indexed journal, 8 other journals. He acted as assistant professor in research grant project in Sultanate of Oman on the topic a novel approach for allocation and scheduling problem with uncertainty by using graph theory. He has submitted for review on the topic screening of COVID-19 pneumonia disease using deep learning techniques in Sultanate of Oman. He has presented 7 papers in conferences and attended 3 national conferences, 4 international conferences, 3 workshops, FDP on random processes and integral transform, teacher training program from NITTR, Taramani. It's our privilege to have you as our guest of honor, sir.
Good morning to one and all. Am I audible, sir? Can you hear me?
Yes, sir.
Are you
Yes,
able
sir.
to see my screen? Yes. Are you able to see my screen, sir? Everybody?
Yes, sir. We will sir.
Yeah. Yes. Thank you, ma'am. Thank you for the very nice introduction. So, I'm Dr. Kishore here from Department of IT Mathematics section from Sultanate of Oman. I'm working for a university here. And first of all, I would like to thank the management and the faculty members and my beloved professor, Dr. Harir Sudan, for giving me this opportunity and taking an effort in this pandemic to do this program successfully. And it gives me immense pleasure to be here with you today to talk about some of the concepts in mathematics. I do say, like already, ma'am have covered almost all the application parts in mathematics, like all the mathematical concepts involved in engineering. But still, I would like to summarize those things. I will not be going in depth with all those equations. I'll be just showing the outline of where you're going to use these mathematics concepts and and in what branches, what are the mathematics topics involved. So we will just see that, and I will just navigate through my screen. Are you able to see my screen, everybody? Yes.
Uh,
So yeah,
PPT open
yes,
up.
sir. Can you see my screen, sir?
ஓப்பன் ஆகல. நீங்க சொல்லுங்க.
Sir,
ஓப்பன் ஆக
Sir, your PPT is not open, sir.
not open. Okay,
Yes, sir.
1 minute. Just give me a
no.
minute. I will. Uh,
ஈஸ்வரன் இது வரேன்.
are you able to see the screen?
Yes, sir.
Yes, ma'am. Yeah.
Yes, sir.
I will make it. I will make it full screen now.
Okay, sir.
Please tell me. Yeah.
Yes, it's doable, sir.
Is that okay?
77
Fine.
77.
Yes. Fine. So let me continue. So first of all, we just want to know where mathematics is involved from our childhood actually. So everybody knows mathematics without knowing what it is exactly. Something like actually, suppose you are giving five chocolates to a kid and you are giving only two chocolates to other kid. Automatically, the one who has been given more chocolates will be surprisingly very happy, and the other one will be little sad. So the concept behind this is like the child knows that it has got high quantity than the other one. Okay, so obviously it brings happiness to that child. So without knowing what mathematics is, it is there in our blood actually. So we just want to bring it up with a lot of thinkings and abilities, and we will be just I will just go through these things. I mean, in this slide, which you could see right now, mathematics is the queen of science. So the only way to learn mathematics is to do mathematics, and mathematics is it is not about numbers, equations, computations, algorithms. Okay, it is about the understanding, the way in which you understand yourself, and the way in which you are going to practice actually. So this comes only through writing actually. It is not like your other subjects like English or some other subjects. Just by seeing or visualizing, you're going to get the concept. Of course, visualization helps in some level, but to write it and practice more and to give importance to what you're going to do exactly is going to help you out at the higher level. Okay, so at the end of the day, what you're going to take, it's very important. So you need to understand what you're going to do with mathematics, right? So mathematics is essential in many fields like natural science, engineering, medical science, finance, and social sciences. Okay, and it has got its own significance in solving any real-time problem. So any problem, okay, it is not only engineering problems. Any related problems you could approach with mathematical concepts, and definitely you will be getting an optimum solution. That means even though it can't give an exact solution, sometimes you will be approachable towards the approximation. So there comes mathematics, which is giving which is playing a vital role, okay, in solving the problems. So as everybody knows, the various branches of engineering, what you're gonna see, I mean, what you have been enrolled in the college. So there are various branches like mechanical engineering, civil engineering, electrical and electronics engineering, electronics and communication engineering, electronics and instrumentation, then computer science engineering, IT, information technology and automobile, chemical engineering, biomedical engineering, textile engineering, etc. Okay, there are a lot of engineering courses which are very uh, very useful in finding a good career to a candidate, to a student actually. So whenever you start with the engineering course, definitely you will be dealt with a lot of mathematical concepts. Okay, so once you read your schooling level, like your 10th, 11th, and 12th, so the 11th level mathematics has got more weightage than your 12th standard level, because it has got a lot of fundamentals. So you need to understand more in your 11th standard level, so you will be getting familiar with 12th level maths. So once you complete that successfully, then it will be used in some courses, not in some courses. Like if you are going to be in engineering stream, depends on your stream, wherever you are going to study some concepts in the other papers. Okay, you will be having a lot of stuff in mathematics involved in that. It is just embedded with that, the problems inside each and every topics you are going to study. So you have to have a focus on that particular thing, what you're going to study exactly. So suppose sometimes a student tells like, sir, I missed differential calculus in my 12th standard level. Without that, I have completed my 12th standard. I just thought like, it will be only few marks, which is not going to give me much weightage. So I just cleared that without doing that. So it is not going to be, like a case in engineering. Okay, if you want to study engineering course, then you will be having lot of involvements in calculus, especially like your calculus, advanced calculus, like differentiation, integration. Okay, a lot of concepts, and then differential equations. Okay, like ordinary differential equation, partial differential equation. You have a lot of things involved in differentiation level. So you have to have a lot of focus. If you have not studied also, you have to make sure that you're going to study it again just by brushing up your 12th standard level books. Okay, that's going to be enough, right? So now let us get into some concepts which are involved in electrical and electronics engineering. So mathematics embraces many applications for computations in electrical system. Okay, suppose if you are going to become an electrical engineer, definitely you will be working on the power systems, and definitely you will be working on the electrical circuits. Okay, you have electrical circuit one, electrical circuit two, lot of papers you have in electrical engineering course. So especially mathematics derivations are carried out more in those concepts. Okay, so the fundamentals like Boolean algebra, set theory, and functions are essential for computing various parameters in that. And also, you will be studying about logic gates and all those stuff. Okay, which is having a lot of mathematical knowledge. Okay, to work on. And the majority concepts in electrical and electronic engineering programs needs some applications of linear algebra. Okay, linear algebra is one of the important tool which you're going to use in electrical engineering field, especially in solving the problems when you make it as a matrices, and when you want to work with MATLAB. Okay, like control theory, etc. So you have to have a focus on those particular concepts. And of course, a lot of concepts involved in electrical engineering courses, of course, deal with mathematics only. So here we have matrix algebra, then we have system of linear equations, then determinants, vector spaces, then non-linear spaces. Okay, then we are just going to work out with some concepts in functional analysis. Okay, and then linear transformations, and of course eigenvalues, eigenvectors, and quadratic forms. So these are some topics which you will be studying in your first year level. Okay, so it is not like when you study first year level, later you will forget that mathematics and get into your second year like, sir, I have just crossed my first year level, then I don't want to have these things in my mind. It's not like that. You have to take this very seriously. Only then you can be able to do your second year math courses, or the other, I mean your core courses, like electrical circuits or other papers. Okay, then electromagnetic theory, something like that, so which has got a lot of concepts involved in mathematics. So you have to be very clear in what you are going to study in the first year level, because in those days it was a semester non-semester pattern. Nowadays we have the semester pattern. So the subject has been it has got a breakdown, like 2 semesters you're going to study that. Okay, so the breaking point is there, so you can just try to manage with that concepts, and you can understand it very well. Okay, so you can apply it in your higher level, right? So these are the fundamental things which you have to know. And then coming to some advanced concepts, like we are going to apply even complex analysis, which you have studied in your 12th standard level. Okay, so it plays a very important role in electrical engineering courses like signals and systems. Okay, then control theory. Okay, so these concepts have a lot of involvements in complex analysis because you're gonna predict some results out of it, so you're going to compute something, so we have to use a lot of concepts with mathematical coding. Okay, like we have to involve it in MATLAB, okay, programs. So for that you have to essentially have this idea, okay, about complex analysis, and of course some geometry, okay, which plays very important role in electrical engineering. It's used to design the power systems, of course, and then computational geometry is also used to design any any electrical circuits which are going to be manufactured. So these topics are dominating in these courses, so you need to be very alert when you give importance to mathematics, what you're going to study more. When your first year level itself, you can be very strong in this courses, okay, because first year mathematics has got a lot of topics, okay, which is involved. It is a common mathematics, okay. So what you're going to take with for engineering, electrical engineering course, these topics you need to concentrate more. And of course the very important topic is vector analysis, because it plays a very important role in electromagnetic theory, okay. And there are some theorems like Stokes theorem, Gauss divergence theorem, okay, like you have to use double integral, triple integral, then surface integral. A lot of things we have to carry over to work on in your core paper, okay. So as an electrical engineer, when you come out at the final year level, so if you want to clear the higher level, exams like GATE or any other exams, you need to be very, focused on mathematical part there. So just to complete the course, I mean the degree and come out may not be sufficient nowadays. So you have to be competent enough in the world market. So for that, you need to have more focus on these areas, right? Then we'll be talking about of course, yeah. Again, we have to know about some other concepts like Fourier transforms, okay, Fourier series, which are very important. This will be you will be studying this in the second year level, like in your transforms and partial differential equation. There is a paper, so there you will find a lot of concepts involved where it's going to be useful in your again your core papers. It is used to convert time-based signals into frequency domain based, and you will be working on it. So then you will be knowing the importance of Fourier transforms, where it majorly focus on the the configuration of channels or transmission mediums in the real-time network. So a lot of this microprocessor concepts and micro tower concepts involves this Fourier transforms applications. Okay, along with that you have some Laplace transforms and Z transforms also, which is used. So again, to talk about control theory, these are very much helpful in it plays a vital role in doing the problems done. So because as I already talked about it, so I don't want to mention it again and again. Right. So these are some areas you have to focus in your electrical engineering course. Right. Then talking about electrical and communication engineering, so this course is majorly dealt with a lot of mathematical concepts involved, especially the concepts which are very rich in mathematics is applied in communication engineering. Okay, so you are the one who are going to study more mathematics, especially. So you have to be very careful because a lot of courses involves the mathematical concepts. So it doesn't mean that like I'm just making you scared like why sir I took this course, not like that. It is very quite common in all the subject. When you love it and you study, it's going to be helpful. So again, Fourier transform plays a vital role in communication engineering, okay, and especially subjects like signals and systems, digital signal processing, okay, which you will study in your third year level. So which is very very important. As a EC student, you have to take more care on these subjects, which involve a lot of mathematical concepts into it. So a diagram put into this here, it is called as butterfly diagram. So you will be just focusing on this kind of diagrams when you come into this kind of, I mean, these papers, when you study these papers, and it requires a lot of convolution concepts, and it involves a lot of the transforms, the Hilbert space, and a lot of approaches towards this transforming techniques and all. So for that we will be using some pictorial representation, because you have to just formulate the linear discrete systems in that, and you have to work on it. So this is majorly used in converting the signals into frequency domain, as I told you earlier. And also we talk about image processing, which is very, very important in your paper. So image processing is one of the topic which is, in recent trends in research, not recent trends, it was for a quite a long while we are working on image processing. It is useful for, to make the image, it's, to make the image process very well. That means you can eliminate the noisy data and bring out the exact picture. Okay, so for that we are using a lot of techniques nowadays, a lot of logic we are approaching with, like fuzzy logic. We have some concepts in fuzzy, and then we have some concepts involved with wavelet transforms again, like Fourier transforms. So here we are using some concepts in mathematics more, okay, to work on images. Okay, so this is one of the hot topic in your subject, so you need to be focused on this thing. And then this is used to filter the noisy data by using linear time invariant discrete systems. Again, you will come to know about what is what, okay, because as of now you will not be having much idea with what I'm talking right now, because I can just talk about mathematics alone, which already has been dealt by ma'am. So I just want to just show you the outline here. Okay, so as a ECE student, you should be focusing on these concepts. Again, when you get into higher level, like you will be studying about antenna wave propagation paper and all, which has got a lot of applications. When I was teaching in this college before 15 years, I used to take a paper like applied mathematics for electronic engineers in master level in ME course and all. So there we had a lot of concepts involving this, Fourier transforms, numerical methods, and all those stuff. So to be very rigid, we have to stick on with this topics, okay, this mathematical concepts very well. Only then you can proceed with your, higher level courses successfully, scoring very good marks. Okay, so please try to take care of these topics, right? And then talking about mechanical engineering courses, actually people just join mechanical engineering. Yes, my friend told I have joined mechanical engineering, or my father told me to join this course because he is a mechanical engineer. Actually, what I say is, like, when you have a passion towards what you're going to learn, please join that course. Especially when you join these courses, you have a lot of mathematics, no doubt about it. So it seems like the course is going to give you, more what to say, like proudness after you complete the degree, and it is definitely going to give you a very good certification. So for that you need a lot of skills in mathematics. So when you start with mechanical engineering courses, the other course what you're going to study with mechanical engineering is like engineering mechanics. It has got a lot of physics and mathematics involved, especially the mathematical concepts like statics and dynamics, which are very useful in doing the problems in engineering mechanics. Okay, so when you study engineering mathematics, that definitely it's going to help you with this the other papers what you're going to study. Okay, and to pursue your higher level, I mean the forthcoming years. So you have to be very careful in this also. You have to concentrate more on this papers. So majorly some concepts in trigonometric identities, trigonometric laws. Okay, and to know about decomposition of vector quantities. Okay, so we will be using a lot of decomposition methods, okay, to define some properties, okay, to solve a problem. Then we'll be talking about moment of a force, then dry friction, equilibrium of rigid bodies, etc. These concepts are majorly based on mathematical way of approach. So you have to be very careful. You have a lot of equations, and especially differential equations plays a major role in mechanical engineering, because you have to be you are going to use a lot of concepts involving mechanics with this differential equation approach, especially fluid dynamics, fluid mechanics, okay, heat transfer, then thermal engineering, thermodynamics. Okay, so all these courses involve a lot of mathematics, so you need to be alert. So when you want to solve some differential equations, especially the partial differential equation, sometimes it is very hard. So we will be approaching it in other method rather than analytical approach. We will be having some more approaches like numerical methods to solve the problems easily, to get an approximate solution. It is not going to give you the exact solution, but sometimes you are reaching to that solution, leaving out the errors. So that will help you to solve a lot of problems. Okay, and of course you are going to use a lot of softwares, okay, in your course, so to solve this kind of equations. Okay, so one of them is MATLAB. Now we have a lot of programming softwares like Python or etc. to work on the concepts. So especially your course involves a lot of designing softwares like AutoCAD, etc. So which is going to give you a lot of results. Okay, so that also requires mathematical measures and all those stuff behind it. So when you want to study these courses, definitely mathematical concepts are involved. And then determination of the deflection of beam when a load is placed, that is using differential equations. Again, you can solve it, okay, and you can just get the answer by integrating it. So differentiation and integration are just proportionally equal. So you have to be very alert to solve problems based on this. Okay, you have to read these concepts very well. Okay, you have to focus on that areas. Then about numerical solutions, as I told you, it also involves many application parts in your mechanical engineering courses. Then here I just show a picture. Here you can see kinematics of machines. There is a paper. It involves a lot of mathematical concepts. Then you have the other courses like strength of materials. Okay, then uh, other mathematical courses like thermodynamics. Okay, all those things which has got a lot of mathematical involvement. So when you see those books, okay, actually you will find a lot of mathematical problems solved. I mean, a lot of identities which have been solved in a problem, and from where it comes, how it comes, everything you have to know. Okay, so when you simply read the book, you will not be able to understand sometimes how they approach with this result. All of a sudden, there will be a result, and from where does it arise? Actually, we have to be very alert. Like we have to solve that part, and we have to understand it is mathematics there. Okay, so it is not like you are going to study your mathematics in first year level and just skip out just studying with some mathematics in second year and forget it. Not like that. You have to focus on some important mathematical approaches for your course, okay, which I told you here. Okay, so please do concentrate more on differential equations and numerical methods papers, which will be giving you more concepts at last to work on with your papers, right? Then talking about civil engineering courses, again, civil engineering branches involve much applications of mathematics. Okay, so even though people tell, "Sir, I am into construction field, I am into interior design field, lot of things," but actually, you can see the core of that is it's having the main weightage in mathematical concepts. Okay, especially with calculus. Okay, then linear algebra and so on. We have more involvements of in different papers which you're going to study. Okay, so again you will be studying some concepts like mechanics of solids. Okay, which includes topics like internal forces and deformation in solids, stresses and deflections in beams, okay, and column theory analysis, etc. So this involves some mathematics. Okay, and definitely you have to be strong with some calculation parts. Okay, especially when you want to study this, you have to be very good in calculus. Okay, both the differential calculus and integral calculus. Okay, because you'll be studying about the differentials, and you will be studying about the directional vectors. Okay, you'll be studying about the directional field in that. Then you will be studying about some concepts in Stokes theorem, all those things. So you have to work on mathematics again. Okay, so you have to concentrate on those areas, and of course linear algebra plays a vital role in solving some concepts using matrix analysis. So again, coming into this topic, you have fluid mechanics. Okay, where you'll be studying about the fluid, the nature of the fluid, properties of fluids. Then you have to study about the shear stress there, and you'll be studying about fluid dynamics and dynamic similitude to analyze the flow of compressible and incompressible fluids in closed conduits. So this and all will be like Greek and Latin right now. Why? Because you are just entering your engineering course. But when you come to the core paper, you will be coming to know about this. Okay, soon. So what is what actually? Okay, so you have to be concentrating on these areas. So of course, civil engineering doesn't mean it don't have mathematics. Okay, it has got a lot of mathematical concepts involved. It has got a lot of computations. Okay, again, so you have to focus on these things. Okay, even though you have a lot of theoretical stuff involved, it has got again a lot of mathematical concepts embedded together. Okay, so it is just designed, these courses in civil engineering are just designed with a lot of approaches in mathematics. So the role of mathematics is given high. Okay, given priority high in this engineering course. Okay, right. And then we'll talk about some topics involved in computer science, engineering, or information technology. So most of the students actually, since it's an orientation program, I just want to talk about these things, just deviate myself little. So I just want to tell you the difference between a computer science engineering course and information technology. Okay, so a CSE student will read more concepts on programming, especially. Okay, he or she is going to take up a programming, subject, and he or she is going to work with a lot of softwares. Okay, to be very strong in programming. Okay, because you are an engineer, you are going to design the software. Okay, you are into the software exactly. Okay, so this is what you are going to do in your computer science engineering. So it involves a lot of mathematical concepts again, whereas information technology student will also have the mathematical ideas. Okay, definitely they are also having the equal weightage, but they can focus on any areas. For example, if IT company is recruiting you sometimes, then what you are going to, not sometimes, you are the student who is eligible to do go into IT company. Okay, I'll just talk about the careers at last. So what you're going to do, a computer science engineer will be in the in the team of developers. Okay, as a developer you will start your career. Okay, then you will be you will be promoted as a software designer, their software tester, etc. But a IT student, IT candidate will be recruited for the maintaining the organization with the networking. Okay, or you will be maintaining, you will be a database admin there. Okay, so you have a lot of various, you can just diverge yourself into all the areas in as a software company. Okay, you can manage with the other computer stuff, or towards the networking area, or the areas in database. Okay, that you can concentrate and you can work on it. So that is the difference between IT degree and an engineering degree. Okay, engineer will develop the very strong code. Okay, which is essential for a company. So whereas IT student will work for the client. Okay, where he can manage. Okay, even IT student can work for any domain like banking sector or anywhere, who is going to maintain the network and who is going to work on the computer related issues, right? So this is what I'd like to tell actually, because you have to know the difference between what is computer science engineering and information technology here. Okay, right. So the concepts of logic, of course, is very, very, very important when you want to enter into this field. Okay, because logic plays a vital role, like in programming level. Okay, when you want to make your programming skill efficient, you have to know more about logical skills. Actually, for that, logic is very important, especially the proportional calculus like proportional logic and predicate logic. These are much helpful to draw a conclusion into your program. So we have a lot of concepts involving the program correctedness, of course. Okay, where you will be ending up with whether your program is going to be correct or wrong. You are going to use methods of proofs. Okay, to work on the algorithms, to check whether your algorithm is correct. These are all done by mathematical induction principle and mathematical uh, theorems. Okay, mathematical concepts. So you have to work on it by using mathematical approaches, right? And you have a paper called discrete structure or discrete mathematical structure, which plays a major role in involving many mathematical ideas behind any logic of a program, of a problem approach. So when you talk about discrete structure, actually it is the combination of various subjects combined together. Okay, it is not like only one course which you are going to study, like one subject. It is having, for example, you have 5 units in that, then this all the 5 units will have different subjects. Okay, just uh, it is gathered together. Okay, to have this course. Okay, it is just embedded together. So this has got a lot of concepts with starting with function set theory. Okay, and then number theory, which is very much helpful in problems like cryptography. Okay, you will be studying about cryptography and all, and what is called as public key encryption, all those things. So all this are having much involvement in mathematical concepts. So for that, number theory is applied. Then set theory focuses on, you will be studying about the concepts of relations also. So what is a relation? Okay, because when you study your core paper like relational database management system, there you'll be focusing on tuples, like you should know what is an attribute. Okay, how to select a row there, what is a relation. Okay, you will be studying about relational calculus there. Okay, for that you need a lot of mathematical skills. Okay, which is having more weightage in these areas like set theory, then relation. Okay, set theory, of course, relation of course follows from set theory concepts. Okay, and then you will be studying about recurrence relations, what is a recurrence relation, and also you'll be studying about group theory. Okay, group structures like a group and rings. Okay, all those things which are having more involvement, and also we'll be studying about lattices, all those stuffs. Okay, in this course. Okay, so you will be, this is a course actually, okay, for a student who is going to pursue his career in computer science engineering. This mathematics is especially very important, even though you study the other courses like your first year level mathematics. Okay, where you study about linear algebra. Okay, and then you'll be studying about transforms and partial differential equations. On those days it was there. Nowadays I don't know what way it has been framed for you, but it will be framed in such a way that you have to focus on some areas. Okay, nowadays the current trend in this area is like we are talking about machine learning, deep learning. Okay, and data science. Okay, so for that concept, okay, especially as a data scientist, you have to build your career strong with mathematical foundations, especially with linear algebra. Then you have to talk about we have to talk about probability, of course, because it is very very important. Okay, to just groom your skill actually, to build your career, to analyze what is right. Okay, so how much you are going to predict, all for all those stuff you need. A data scientist should have the skill in probability, definitely, and of course the statistics, which is equally important. Okay, with probability you need to study more, and then calculus. Okay, calculus, because a lot of algorithms nowadays it is coming with calculus part. Okay, like gradient descent method, etc. Okay, which is going to show you some curves. Okay, how far you're going to predict. Okay, there are a lot of applications like you're going to use linear regression, logistic regression. Okay, and then sigmoid function. For all those concepts you're going to use your calculus. Okay, and linear algebra concepts. So as a data scientist, what you have to learn. Okay, so you can focus with your career after 4 years where you're going to be right from now. Okay, so you can, after 4 years, what you're going to become. So you just mold in such a way that you are going to flourish in that area. Okay, so try to focus on one particular area, because the software gets changed day by day. Okay, so every day, okay, we are getting recent versions of a software in a software company. So whenever you are recruited, you'll be asked to have a lot of different softwares in your hands. Okay, there'll be an hands-on training and session, and you will be into the uh, your working area. Okay, after that, okay, after the bench, right? So all those things, for that and all, you need mathematical skills. Okay, without that you can't approach this idea. So the efficiency of program could be attained when you are very strong in logic. Okay, logic analysis, logical skills. Okay, so how much code you are going to write. Okay, how anybody can write programs with a lot of codes. Okay, but how efficient you are, how much minimal code you are going to write and execute with very minimal time. Okay, the order of time is also very important. Okay, so like exponential time, like that we have some time like log time. So we have to just focus on that areas. We should be efficient to execute the programs. For that, mathematical logic is very helpful, right? Fine. Then again, to talk about some more applications, some more parts in this computer science engineering or IT, we have Boolean algebra, okay, which is very much helpful in studying about logical circuits, digital circuits, okay, which determines true or false of an input voltage, okay, using a logical circuit diagram. So these are all some, for example, I may tell you, like when you switch on the TV, you have on off, right? So you on, it is true, you off, it is false. Okay, something like that. You're going to switch, okay, over the networks. For that, this logical circuits, Boolean algebra concepts are much helpful. Okay, and of course you're working with zeros and ones here. Okay, with the machine language, so you will be taught with what is the concepts here. Okay, more you have to work on this, and you have to be working with the networks. Okay, in your high level courses. For that, this Boolean algebra is helpful. And of course you have a paper called graph theory separately sometimes, or I think, or it is just a paper, a topic in discrete structure, okay, discrete mathematics. So graph theory is much used in analyzing the concept of networks and its flows. Okay, so when you want to study about the networks concept, you have to be focusing on concepts in graph theory, because it is talking about the nodes and links, the connectivity between one place to the source and the destination. Okay, so like ad hoc networks, sensor networks, etc., you will be studying focusing on graph theory part. Okay, so like clustering concepts, okay, you can see this picture. Okay, there is a cluster of stations which are together, and it is just connected to a network, okay, towards the internet in the cloud. Okay, so all these concepts have much applications of graph theory. Okay, because sometimes you need to calculate the shortest path, okay, from one place to other place. Okay, and you will be studying about data structures and algorithms, okay, which is very very important. Okay, where your graph theory actually plays the role. Like you'll be studying about tree concepts. Okay, we'll be studying about binary search tree. Okay, then depth first, breadth first search, depth first search algorithms and all. Okay, hop counts algorithm. For that, this graph theory concepts are much useful. Okay, and there are some concepts involved in finding out the shortest path, like Dijkstra's algorithm, Prim's algorithm, Kruskal's algorithm. These are some algorithms which are helpful to find the shortest path in a network. Okay, so all these things requires mathematics. So that is what at the end of the thing, what I want to tell is all these things are involving much mathematical concepts. So you have to study this concepts every year. So a computer science student should have more knowledge on linear algebra first, okay, and of course calculus, okay, very very important. Then probability, okay, the third paper, and finally graph theory. Okay, these are the four components which are going to design your career actually. Okay, so you have to concentrate on these areas. So you may think I can study this and leave again. Again, I'm telling you, in all the core papers which you are going to study, this will be coming. Okay, behind the screen, this mathematical concepts will be there. And of course, if you study very well, it's like a cakewalk for you. Okay, so you can just take whatever you want and you can play around with that. So that's very useful for you, right? And then we talk about some courses like biomedical engineering, which is also a very recent developed courses, okay, in bio field. So this biomedical engineering courses are very important nowadays, like to help the doctors identify the predictions of the disease, or sometimes to the or manufacturing of the medical device, okay, which is used artificially for a patient. Okay, for that you will be studying about biomedical engineering. Okay, so of course a lot of counseling courses are also involved. A biomedical engineering will have a lot of courses in this 4 years what you're going to study. So basically a biomedical engineering needs a strong mathematical skill for analyzing and designing medical solutions. Okay, and then here also, sorry, a lot of calculus and geometry skills are required, okay, to design a medical equipment artificially. Okay, sometimes you will be required to make a pacemaker, okay, for the heart, or an artificial pancreas sometimes. So all this involves the measurements and how far the device is going to be used. Okay, you have to calculate the lifetime of it. For that, a lot of differential equation concepts are involved. Okay, so, and also you have a lot of concepts involving mathematical modeling, okay, which is very very important in bio field. Okay, we have something called dynamical modeling nowadays, dynamical modeling of a system, which are dealt in depth to simulate the behavior of real time biomedical problems. Okay, so to study all these concepts, okay, you need mathematical approach. Okay, you will be studying about differential equations. Okay, especially the linear differential equation, non-linear differential equation, all those things you will be simulating using the software. Okay, there are a lot of softwares like this MATLAB, JSIM, etc. Okay, these are the softwares which are there to simulate the the mathematical modeling, okay, problems, and also to approach with the solutions which you're going to give, which is going to be efficient. If you want to test it, then you are going to study about optimization techniques, okay, and computational methods which are much used in biomedical field, okay, biomedical applications. And also the applied statistics which are very helpful, okay, in calculating the mean, median, all those stuff, okay, to calculate the average life, okay, the reliability concepts, okay, the reliability of a device, okay, how far it is going to exist, okay, all these things, okay, reliability, availability, all those concepts are the mathematical concepts again, okay, and statistics plays a vital role in this medical analysis and biological sciences, okay. So again, to talk about this engineering course, again, nowadays, even the computer field has been, working with the bio field nowadays. Like just it is merged with biomedical concepts. Okay, the medical analysis concepts like prediction of cancers. Okay, using machine learning, deep learning techniques. Okay, you have a lot of algorithms to work on it. Even a biomedical engineer can approach and he can work on those areas. Okay, can just check the average life of a device, okay, how far it exists, okay. And there are a lot of you can see this picture, there are a lot of other areas you can concentrate, like biomaterials, okay, how do you form the device, okay. You can see this aortic aneurysm and repair with synthetic graft material, okay. What are the material which you're going to use in your device formation, all those things. Then biomechanics, okay, like suppose you are thinking about a tumor growth, okay, like you are going to work out with markup analysis, something like that. Then how far it's going to the approach, how far it's going to predict the metastasis of a cancer, all those things you can use your biomechanics field and you can work on it, okay, which involves mathematics. Then as I told you about biomedical modeling, okay, where you are going to work on as I told you, to equip a device, okay, how far it is going to be compatible with a human body, okay, the lifetime, all these things you can measure by simulating that model, okay, and to work on to just see how far it's going to be efficient. And the biomedical devices, okay, like see this ear height device and all the other devices which has got the mathematical application, because you need a lot of geometry there, okay, to design a device, as well as the calculus, okay, about the lifetime prediction, how far it's going to be uh, good enough, okay, to fit into a patient. So all these things are very essential in biomedical engineering. That means all these things focus again with mathematics concept, and it involves a lot of mathematical analysis. So these are some applications. I could say, I could not say like applications. I'm just telling you about the role of mathematics here in all the branches. And I'm really sorry that I couldn't able to tell more about the other engineering fields. Of course, all the other engineering field requires these core fields. Okay, so they are just relying on these fields. Of course, they also have the equal weightage of mathematics what they're going to study in this engineering fields. Okay, so why I focused on these particular courses is like now this is just the booming areas like these engineering courses, like because a student just joins an engineering course without any idea like what is engineering, what you're going to do there, like. So the first year engineering course will give you, which has got a prerequisite of your 12th standard level physics and mathematics and chemistry and etc., which has got a lot of weightage, okay, which you are going to study it again, of course, in your first year level, just to make the just to brush up with this concept, you groom yourself prepared for the second year level with your core courses there, okay. So for that, mathematics is very important, okay. So uh, the topic given for me is mathematics, so I just talk about this. It is just like you are going to end up with other courses eventually, like engineering chemistry or engineering physics, which is also involving a lot of mathematics, okay, and which is equally important like mathematics, okay, to work on this areas, okay. We work on your core engineering from your second year level, second year core, and up to your final year level, right. So these are some engineering courses where your mathematics is involved. And now I would like to talk about some careers which are going to be useful for you. I'll just deviate because it's an orientation program. So I just don't want to stick on to my topic alone, like just mathematics in engineering. Okay, I just want to tell you about the outline, because I've seen hundreds of students in my in my teaching career, okay, from starting from SA Engineering College, which is my first career, okay, like I started as a lecturer, working as a lecturer in that college first. So I've seen a lot of students from that just for the past 15 years up to the students who are in this country even now. So see, any student who is going to study the engineering course, like he or she doesn't know about what are the core companies which recruit, okay, your for your course, because many people who are telling like, sir, I studied EC, I studied triple E, I studied electronics, sorry, mechanical engineering, finally, and I end up with a software company. Why? Because software company has got a name, and like it has got a brand actually, so you are just thinking like it is just paying you well like that. So for that you are just, to immediately get the benefit, okay, you are just joining a software company. So I'm not telling that it is not a good thing to do. You can just select your career in that path also. But the thing what you are going to learn in your career, like the electrical engineering, electronics engineering, mechanical, okay, your core subjects, where it goes at last, okay. So at the end of the day, what you're going to see, that is very important, okay. So for that you can see, because nowadays any IT company, they're just coming, whatever engineering just come, just take a training in software and you become a software engineer, not like that, okay. So please try to concentrate on what you're going to be at last after your final year, where you're going to end up, okay. So because the hard earned money of your parents as well as the knowledge of you, okay, you are going to put more efforts, okay, all these things should be fruitful, okay. So there are some companies where which gives the where a mechanical engineer could start a career, like Tata Motors, HPCL, okay, Kirloskar, Ashok Leyland, Thermax, Bell Limited, Larsen L&T, NHPC, DRDO. DRDO is a very big best option. Like it's a government sector where you can just start your career. Okay, like you can just join as a, you can write a gate exam and you can just start as a research assistant there, or you can do your even your master level and PhD integrated together. Okay, so there are companies like just Gale. Okay, about then ONGC, ISRO, Bosch India. These companies are, recruiting mechanical engineers actually. So try to focus on your core areas. Okay, initially you will not be getting, the more more package. Okay, a decent package, but through experience you gain a lot of things inside, and finally you will be ending up with what you have learned and what you are going to do as a job, which will definitely fit, okay, which will be tallied there. So some of the companies recruiting civil engineers like Gammon India, L&T again, JP Group, Slanco, Infotech, then Hindustan Construction Company. These are some core companies where you have to focus. You can just see the the requirements of the company, what they ask for. Okay, so focus on that and you study that things. Again, to study that, you have to focus on your mathematical skills, and I don't mean only mathematics. The other, your course, you have to be very strong enough in your the papers what you're going to study in the course. Okay, then electrical and electronic engineering requires, they those people are recruited in this NIVE, okay, National Wind Energy, okay, Institute of Wind Energy, then Indian Railways, NHPC, DRDO, ONGC, IOCL, okay, these companies recruits electrical engineers. Then electronics engineers are recruited in BSNL, DRDO, ISRO, Bell, Indian Engineering Services, RRB. So these are a lot of options you have actually, okay, because no need to stick on with one particular thing. Okay, you should know after your engineering where you're going to end up. So that is the reason I just put, out of my own interest, I just added this part. Okay, if it is not relevant much, I'm very sorry, but still I just want to make you know what is this. Okay, and then of course computer engineers end up with a software company. Okay, so you have some premier companies like TCS, CTS, Wipro, Tech Mahindra, Accenture, Hexaware, Honeywell. Okay, of course HP, Dell, Deloitte, Amazon, Facebook, Google, Zoho. All these companies recruit software engineers as well as the IT analyst. Okay, so you can just uh, focus on these companies, okay, to groom your career, to start with your career. And biomedical engineers also have a lot of opportunities here and abroad, of course. Okay, here in Oman and in Gulf countries, you have a lot of opportunities in many healthcare sectors. Okay, some of the opportunities in India I just mentioned here, like NHM. Okay, then Jipmer, Ames, NART, Saigen Group, Trans Healthcare India Limited. So these recruits a lot of, the initial biomedical engineers. Okay, without any experience, you can join as a fresher and you can groom your career. Okay, so these are all some industries in where you can focus, okay, after your degree. Okay, so don't stick on to the course what you're studying. Okay, just know what is what around you, and then you can be a successful engineer at last. Okay, so don't be bookish or don't stick on to the book alone. Okay, nowadays Google is there, you can just surf and you can get a lot of information. Okay, you can be built yourself, okay, successfully. Yes, so thank you all. This is what I would like to convey today, and I'll be very happy like if you follow these things sincerely and step up with this concepts and make your career successful. Thank you so much. Thank you all.
Thank you, Kishore. Thank you, Dr. Kishore Kumar, sir.
Thank you,
Very
sir.
nice presentation. Give the
Thank you, sir.
entire applications of orientation program in mathematics.
Thank you, sir.
Thank you,
Thank you.
Kishore, sir. Thank you.
Thank you, sir. Thank you. Thank you so much. Thank you, sir.
Once again, thank you. Once again, we will meet students tomorrow, as usual, same time, 9:30. We will meet tomorrow. Thank you. Thank you, sir. Thank you.
Thank you, sir. Thank you, sir.